Hello, and welcome to the Data Engineering Podcast, the show about modern data management. This episode is supported by Code Comments, an original podcast from Red Hat. As someone who listens to the Data Engineering Podcast, you know that the road from tool selection to production readiness is anything but smooth or straight. In Code Comments, host Jamie Parker, Red Hatter and experienced engineer, shares the journey of technologists from across the industry and their hard-won lessons in implementing new technologies. I listened to the recent episode, Transforming Your Database, and appreciated the valuable advice on how to approach the selection and integration of new databases and applications and the impact on team dynamics. There are 3 seasons of great episodes and new ones landing everywhere you listen to podcasts. Search for Code Comments in your podcast player or go to dataengineeringpodcast.com/codecomments today to subscribe. My thanks to the team at Code Comments for their support. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst is an end-to-end data lakehouse platform built on Trino, the query engine Apache Iceberg was designed for. Starburst has complete support for all table formats, including Apache Iceberg, Hive, and Delta Lake. And Starburst is trusted by teams of all sizes, including Comcast and DoorDash. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst today and get $500 in credits to try Starburst Galaxy, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'm interviewing Sriram Panyam about his experiences conducting large-scale data migrations and the useful strategies that he's learned in the process. So, Sri, can you start by introducing yourself?
I'm Sriram. I'm currently the CTO at Diagnose. We build tooling for automating runbooks for SRs and dev teams to kind of get out of all the manual repetitive work. Right now, I focus on SaaSifying our platform and building its control plane. But my background has been in data for a while, especially at in large scale systems like Google and LinkedIn, and one of the concepts that make me passionate about is data migrations and data movement at scale, right? So hey, how you doing?
I'm doing well, thanks. And do you remember how you first got started working in data?
Purely randomly. My career began, in as a network designer, long time ago. I guess what's more data than packets sitting around, eh? But to me, I think almost any useful or effectful computing is about moving and processing data. And I guess my journey was about 15 years ago when I started doing my first startup back in Sydney. It was called Street Hawk. It was a location-based marketing platform for matching retailers and shoppers, as they are walking past based on location. And it was a really interesting, evolution for me because prior to that, I was a embedded systems kind of engineer, working on device drivers and games, right? So the best thing or the closest thing to data was how do you load really large asset files for games. When I started getting into web, even though it looks like, hey, user comes in, gets a page, downloads something, goes away. There's so much behind the scenes in terms of how data is managed, loaded, moved, kept consistent, kept clean, despite bugs happening all around. And that was kind of the start into my world in startups, into data, into large scale systems, and moving into the US around 12 years ago just made that more fun and accelerated for me. Later on, I was at LinkedIn working on the profile and feed platforms. Again, a lot of data problems, a lot of fun stuff there. And then, going from a user of these platforms and building the right platforms, I moved on to Google where I was working on data flow, where I was, I guess, selling a platform. That's kind of my journey into data and continual, current learning as I go through.
Yeah, it's interesting when people start from that very low level of, in your case, the network dealing with packets, how that colors their overall experience with other technologies. Myself, I started as a systems administrator, was my first job in
Oh,
tech. And
nice.
so that has definitely very much colored the way that I think about software and programming because I want to make sure that things are reliable and aren't going to break and wake me up in the middle of the night because that's where I started my career.
I saw you did some really interesting things, and I can see that those experiences, even though they may sound very different and offbeat, they really bring a different perspective for you when you solve these problems, right? For example, in the networking world, back then, 20 something years ago, it was all about network and switch design, right? Everything was about how do I relieve load on some processing cluster on some rack on some network, right? And then if you think about data, it's about, okay, I have this giant blob of data, like petabytes of data. I can't process them, in a single core, right? So how do I route it? How do I switch it? How do I break it down? How do I shard it? Like all that comes in as part of this, right? And I think there's a certain bit of gleeful joy, when you bring in those completely different, unrelated topics into something else you're working on, right?
Absolutely. Yeah. And in terms of the topic that we're covering today, the idea of data migration projects, obviously data gets moved around all the time, but when we say migration, that usually means that there is some specific body of work that hopefully has an end, but definitely has a beginning. And I'm wondering if you can just give some of your perspective on what you see as the kind of broad categories of data migration as a project, and maybe some of the ways that people might think about it that we are explicitly excluding from this conversation.
Yeah, yeah. Now, if you are a Seinfeld fan, or if you haven't seen any episodes, there's a really good episode where George Costanza talks about risk management, and how there's a really boring introduction. To understand risk management, you have to understand risk, right? Nothing can be drier and more boring than that. And if you look at data migrations or database migrations, it's very much like risk management, right? If you look at it purely as migrating a database to something else, it can get very dry and very boring, as you called out, right? There's a start, there's an end, voila, off you go. But so much happens when you bring in other constraints, right? If you think of migration or data migration as, look, I have this big system, I need to move it somewhere else. That's it, right? The easiest, dumbest thing you can do is, take a backup, or sorry, first cut off your customers, take a backup, load another database, have some downtime at 3 a.m. in the morning, move your customers, and restart it. That's kind of not how today's systems, well, more importantly, it's not how customers would be happy with you if you did that today, right? They want, near 100% uptime or zero downtime. They want all kinds of other functionality in between. They want, there's so much diversity in the kinds of data in terms of cardinality, the structures and schemes and so on. And and you're talking about global scale, and with global distributions, right? You might have data for customers in America being served out of India, right? So as you start looking at migrations as a data systems problem, right, things get very interesting. Yes, there is a start and there's an end, but there's a very, very interesting middle, right? Which is where data migration tools and strategies and systems really shine and, take it away from being anything of a boring topic, right? For example, is migration not just another form of replication at the nth degree, right? Yes, you might have one database to another database, or one MySQL to another MySQL, or SQL to SQL, or then you can go SQL to NoSQL. Then you're talking about building indexes, as a form of migration. You might not want to migrate the whole database. You can just look at partial migrations. A good example is when you have startups, or any company, right, building a product that's V0 or 0.1, everything gets stored in one database, served through some kind of ORM. Off you go. But as you grow, billion, 10 billion kind of like million, billion, 10 billion kind of records, one database is not going to do, right? Or you'll have to shard it. Suddenly, it becomes a set of partial migrations, right? We talked about different kinds of databases to and from, and then there's things like cardinality, where we can be, are we going from I doing one-to-many relationships, or many-to-many, or even redistribution of things, right? So there's a lot of these interesting cases that come in the middle, when you look at migrations and transformations and moves.
In terms of migrations, usually there's some sort of impetus or some hopeful improvement in your overall state at the end of it. I'm curious if you can talk to some of the typical motivations for starting on a migration project, and then we
Yeah,
can dig into some of the strategic elements of how to think about it, how to plan for it, how to execute it.
yeah, yeah. So there can be different triggers for migration, right? You might just be at a point where you put everything in a single data store, and you kind of reach limits, storage limits, QPS limits. how many customers are accessing it, like what kind of patterns you're doing, they can change. You might have, as your application or platform or API or the client facing thing morphs from day one to day 100, your schemas change, your use cases change, right? Uh, as pure as we want to be, your front end or your application is a reflection of your data, and your data organization is a reflection of your use case, right? So when either of them, so when the use case changes, your data organization is going to change. So a good example is, you might suddenly need a whole bunch of indexes just to make certain queries faster, right? So that might trigger, how often those use cases are exercised. What kind of SLOs do you want on that access? Do you want the same access for viewing my feeds, or same SLOs for viewing my LinkedIn feed versus viewing my LinkedIn profile, right? So those might mean that you're okay with certain sacrifices and certain trade-offs you might need, which might mean that, hey, look, why am I keeping everything in the same database? Move it around, break it up, break it to multiple microservices that other teams can manage. Change ownership. And that results in more reasons for migrating your data. You might even have things like compliance and privacy requirements that might change how your data is stored and retrieved and processed, and what kind of ACLs you might want to have on your data, right? And applying those ACLs may have different. Sorry, applying those access controls might have different, different costs, right? That may not be homogeneous to who's paying for it, right? So again, you might want to break that up to serve different needs and different SLOs. And also, you might have things like, team expertise and team limitations, where certain data stores could be useful for certain kinds of features and teams that team would be good at managing, whereas some teams might be more oriented towards a different class of problems, right? Then you have your whole offline, online, nearline use cases where you want to dump data to some data lake for analytics purposes and a lot more.
In the intro, I also had that keyword of large scale, because if you're just dealing with the data migration of a 50 megabyte Postgres database to MySQL, there's not a lot of planning that has to happen. You just need to make sure both databases are running. You do a SQL dump, SQL load, and then you cut over.
Yeah.
And I'm wondering, what are some of the ways that gradations of scale impact the overall time and effort needed to be able to actually plan for and implement one of these migration projects?
Right. So, looking at the grades and gradations and scales, right? I would look at it as, look, what kind of consistency, what kind of freshness, what kind of, latency requirements, your access needs, right? Now, take something like a 50 megabyte, database that you want to move from one to another. It could be SQL to SQL or SQL to SQL. The size here is a big factor here, right? In this case, a big factor. So, in this one, even if you were to kind of do a manual, physical, one-time cutover, the downtime itself is going to be pretty minimal, right? You might have more effort in testing the migration and so on, but the overall downtime is kind of cheap. It's almost a lift and shift, or a lift and transform and shift, and fairly minimal downtime there for your users, probably in the order of minutes, right? As the data sizes kind of grow, right? You might say, look, I have a petabyte, like a few terabytes of data in some data store that I need to break and move and ship and so on. I can either do it from a streaming perspective, but we'll come to that later. But I can do a full dump and reload, right? We're talking about a few hours, if not days of downtime for the customers, right? Again, if all you care about is the ease of lift and shift, that's fine. You might be okay with your customers having a downtime for a few hours in a very bespoke use case, and that's perfectly fine. In today's system, right, it's not just one access of data that a customer demands, right? It's not just that, hey, I have a bunch of profiles in this database, I'm going to move to the database and start using it. What customers want to do is, I have my profiles that I'm using. I also want to be able to post feeds. I want to create content. I want to like and follow other people's content. How can I do all that all the time without a downtime? And now I need to start thinking about how can I reduce my downtime as much as possible while making this process less complex. The other aspect is, we talked about indexes, right? And if you think about all these secondary, third degree, fourth degree views that you can get from your data. For instance, you might have a Twitter timeline which is a collection of the posts that you can see of all your friends, right? I mean, this is a classic system design problem, right? I'm posting, I want to see all my tweets, but somebody else wants to see mine as quickly as possible. I could be an influencer. What are the consequences of that data getting around here at what point in time? So when you're migrating, so if you look at that as a replication problem, how quickly I can see it, or how quickly I'm okay to tolerate in terms of the wait time, can affect what trade-offs I make in my migration process. So one example is you can use something like a change capture process where any changes to a database, right, are extracted, processed, transformed, and written to a target database. This is the proverbial middle that we're talking about, right? You're reading from the source database, it goes through a whole pipeline of changes, right somewhere. And there are many tools for this, right, that are out there that can do this too. But if you say that I want my freshness to be as fresh as possible, if I write to one database, I want that to be visible in the second system immediately, then you can use something like a dual write approach, which has its own kind of caveats and trade-offs. So the planning is important. Like, you want to plan what kind of experience the user is okay to tolerate, what that means for our business metrics, and how it will impact our own engagement and other KPIs, and then look at how expensive and costly it is to pick which way you go.
In terms of the end goals of a migration, there are obviously a large variety. Sometimes it's you want to move from one database technology to another because it has some new shiny feature you want to take advantage of. Maybe you need to move from, maybe it's for reasons of scale, as we mentioned, where your single node database can't handle the amount of data that you're dealing with anymore. So you need to move to something that has sharding and replication built in, or maybe you need to move to a completely different style of database, maybe moving from a relational database to something like Cassandra for those reasons of scale. Or it might be for cost purposes, where you start off with a cloud data warehouse, but then you start spending $1 million a year on it and you aren't getting all the return on investment that you hoped for. And so you decide to move to more of a data lake or a lakehouse style architecture. Or maybe it's a continual migration process where you need to keep a subset of your data in a pre-production environment for development and testing purposes. I'm wondering if you can just talk to some of the ways that those motivations and end goals can color the overall appetite and the organizational processes necessary to be able to get buy-in and support for that migration process.
Yeah. So your costs, and I mean your costs play a huge factor in this, right? And costs can come in a bunch of ways. Like, there's obviously the raw cost, as you call that, putting something in a data warehouse. Is going to be expensive from a compute perspective and not just storage, right? You're dumping everything. You need a lot of transformational compute there to make sense for the consumers of that of the data stored in your data warehouse, right? And if depending on who it's valuable for, that could be an acceptable cost. Now, what these warehouses and data lakes give you is, well, I mean, the promise there is that you can do all that with very little effort, and there's a whole bunch of ingestion pipelines that give you things out of the box. There's a lot of connectors from all kinds of data sources that you can just dump in, and then people can take advantage of it. If the ROI of that exceeds, I mean, if it's a high enough ROI, and if the return exceeds the cost, it's okay for a certain point in time. But if you find that you're doing all that ingestion of data just for 3 or 4 bespoke use cases, and you're unnecessarily spending all the resources just for that, it doesn't quite need that kind of heavy ingestion, right? And the other thing is, you also have technical aspects, right? Who's going to be managing this? Who's going to be, who's going to manage the start of it? The actual process of continuous or one-off migration, and post migration, who's going to manage the system? Those costs would also have to be looked at in the overall cost of doing this migration from A to B. We also, I mean, one thing I kind of glossed over was security and compliance, right? Like, when you're doing this, what is the security? What is the current state of how secure and compliant your data is? What will be the final state in the target and during the migration itself? So I think these play a decent role in how you choose, when and why and how you do the migration.
Now, so it's very easy to talk about a lot of these aspects of data migrations in the abstract, where you maybe have various motivations, different organizational structures, but bringing it to a more concrete reference point, I'm wondering if you can pick one or two experiences that you've had of actually going through this process of understanding the motivations for why and how fast and where you need to migrate data from and to, and the overall technical and project management process of that, and then the validation and final sign off to say, yes, this is done. I have achieved my overall objective, and now I'm going to go and get a big bonus because of
Well, I don't think I got that big bonus, but
it.
yeah. So at LinkedIn, I joined LinkedIn 2015 end, right? And initially, I was part of the LinkedIn feed platform. And part of the feed was, your user posts, your users' social actions around it, other kind of shares and comments and likes, and social activity. I mean, LinkedIn itself has gone through several stages of data evolution. They started off with I believe it was Oracle first for a long, long, long time, and then LinkedIn built its own like extremely high performant espresso storage, which was a very, very highly shardable or sharded MySQL and based on MySQL in a very sharded way, right? It was essentially a key value store, and the profile also, and the feed also had many aspects in many components in one of my platforms, the social actions. How users like, comment. We had to move that from one espresso store to a different espresso store, right? For a lot of performance reasons, and two aspects they were really important, right? Like, how do you ensure that these actions were generalizable? Previously, they were very much tied to the feed themselves. So we wanted to build a platform where we could take these actions and generalize it across any other entity in LinkedIn for the user. Effectively, what we called it was a edge store or a follow store. Now we called it unified follows for UFO. So the simplest thing was, I mean, we couldn't do a lift and shift at the time because doing so would have impacted about 100 billion edges at the time. And that was just not going to happen in any reasonable amount of time. We, saw a few options. Obviously one of them was lift and shift, and the other one was see if we can somehow do a bulk dump initially, followed by some form of CDC or change data capture. LinkedIn already has what's called data bus. It's a very high performant CDC system, very coupled with Espresso as well, right? Essentially, Espresso, the way it works, I mean, CDC for Espresso, the way it worked was it would write both to the MySQL table as well as the change log in a transactional manner, and that gets picked up by data bus, and it gets listened to by a bunch of other. So our goals for this were quite straightforward, right? We want to make sure that when this data, these edges in the source database was migrated, it was all migrated. We had to make sure that there weren't missing edges in this. Last thing we wanted were customers, liking something and finding that those likes were missing. We wanted to make sure that the migration was repeatable. Just in case we missed something, we wanted to kind of go back and fix parts and patches of it, as opposed to go through a full migration process all over again. Our original target was to make sure the client did not have to change, as in the LinkedIn user-facing clients don't have to change. And I'll get to how we worked around that or worked through parts of it. We also wanted some testability on it and see how this affected any impacts for the customer. Load times are critical for engagement on LinkedIn, or the impacts, or to improve engagement on LinkedIn. So we had to make sure that those were monitored, and obviously we want to make sure that they were consistent. We didn't want to have out of ordering of writes affect any of the consistency and correctness of the edges before and after. By the way, the schemas were different, so that's a key part of it. It wasn't a homogeneous transfer from the old to new, right? So the series, so we took a two-part approach to this. One was, at any point in time, we would take a dump of these databases or the source database and load it into the target DB. Now, the taking a snapshot wasn't your typical snapshot process. We would have hourly and or daily snapshots saved into HDFS from our Espresso stores, right? So we would use that and the LSN or sequence number in those snapshots as the initial load at any point in time. The CDC would store these changes from the database into, I believe it was Kafka at the time, right? So you can just read those Kafka topics and write back to these systems. Now, because because our follow source was user, right? It could be any entity, but we chose the source as a sharding pattern. So we can pick for any source, only look at changes for that source in the last 1 day, 7 days, 30 days, and so on, and replay that when we need it. Now, once we set up this pipeline, we wanted to see if we can play along with more of the freshness of writes, because we wanted users to have their own writes available to them on both systems. So we did take on a dual write approach in this. Now, dual writes can be, I mean, they're very simple. You have a single client. The client writes to both the source and target database, and you also do a backfill of data from the source to data, so source to target, through some kind of either CDC or some kind of replication method. Now, it looks simple, but there's so many things that can go wrong here, right? If you look at the traditional dual write, you do this write to both, read from both, validate, do transformations, and off you go. So when you do this, if you had distributed transactions, that can be a problem. Thankfully, on the client, or at least on the API facing layer, we knew that writes to a single user's follow, we could send it to the right shard. We had routing at that level. We didn't worry too much about backups at the point because we were depending on the hourly, daily HDFS dumps to take care of those backups for us. We also didn't focus too much on disaster recovery because those mechanisms existed on individual databases. We could always fall back on these snapshots to do a recovery rather than falling back on the DR aspect of it. Yeah, so this process took about, a month and a half at the time. The initial load was the longest at about a week, and then bunch of incremental testing of these CDC and DLR combinations to make sure that our consistency was in place. Now, one challenge was how do you handle deletes? Because in sometimes CDCs may not give you the right kind of delete events, and that's something you have to be careful of. Thankfully, Databus had a mechanism to store the right delta on deletes as well. So you're able to use that to ensure that deletes were properly taken care of and there weren't any new follows or new edges on this target system that were deleted from the old one. On the client side, there were a change of schemas, right? So we ensured that clients were migrated in a way, so the schemas themselves were compatible in a way that both old clients and new clients would continue working. So the old clients would come to the old system, and any new fields that are added to the new schema would have both the new and the old values in it. So even if the old clients are reading from this one, they can have the old fields in there until the old database was fully deprecated and removed. This whole process, the actual migration step took about 6 to 8 weeks, roughly, with a whole bunch of testing following for a few months. It was a reasonable success with, I don't think we had any major downtime, and it's still in use. Now, the bonus, I don't know, I should talk to somebody about that.
Yeah. I wonder if there's a statute of limitations there.
I hope not.
And in terms of these style of projects, there's the inherent risk that it starts, you get underway, you're in the thick of it, you get to what you think is the end, and then the goalposts keep moving or interruptions come along, and so it becomes a perpetual migration. I'm wondering if you can just talk to some of the other risk factors that are involved in embarking down the path of executing a migration and some of the other failure modes that you've experienced.
I don't know if I can talk about the politics of this, but so like any project, right? When we started off doing this, the initial goal was, hey, a user has a bunch of things they acted on. And I use that very vaguely. A user can like, share, do X on another entity. And initially, this was user can just do like, comment, share on feed posts. Now, being engineers, both from our own kind of ambition, as well as trying to get buy-in on this from other parts of the organization, it ended up becoming any entity to any other entity action. Effectively an edge store, like a very, very general purpose edge store. You can do this, but it becomes a very, very large scale project, pretty much migrating every entity in LinkedIn and every one of its relationships to every other entity in LinkedIn. That would have been a multi-year project, disrupting many, many, many fields, like many features and products within LinkedIn. And we obviously wanted to start with a smaller scope, so we settled on a user to select half a dozen entities. A few other actions along the way, because there is a temptation to kind of do everything, because it is obviously glorious, but you have to kind of put a line around that V0 or V1 before you start taking more things on. You might find that the other things are nice to have and may never actually materialize for resourcing and prioritization constraints.
And
I know I'm being intentionally kind of vague there because it'll be giving away too much
Yeah, that's I
between.
I totally understand. No worries. And through your work of interacting with these systems, planning for and implementing some of these data migration projects, I'm wondering how that has influenced your overall thought process and approach to the design and implementation of data systems, data infrastructure, and also the maybe modeling architecture that's involved, and some of the overall initial planning process that you have factored into the early stages of
Yeah,
building these
yeah.
types of systems because of that.
When you do a lot of these, you learn a few best practices and you learn along the way. And I feel like despite that, we will still make these mistakes and repeat them every now and then just for sanity, just for a reality check. But regardless, right? I mean, like anything else, there are a few things that can help reduce the risk of any migration. And I think having a really, really, really good plan and seeing who the stakeholders are and knowing what the current state of all your metrics and all your systems are is very important, right? In the case of the follows migration or the edge migration, we kind of had an idea of who the customers were. It was LinkedIn feed. Yes, later on we found a few good use cases for how can you apply that for companies and pages and so on. But having that initial plan and knowing what a rough endpoint looks like was kind of key. I mean, even with that, we had to analyze what the source, like what the starting point was, what the starting data store, and the type of data and the cardinality. All that was key. And I mean, we gave it the right project management rigor like anything else. We came up with a migration plan. I'd like to think it was detailed, and looking back now, clearly we missed a few things and it wasn't detailed enough, right? But starting off with what you thought or what we thought was a detailed plan was a good point, right? Getting that reviewed, vetted by more senior folks, more experienced folks, or even talking to other teams that have done something like this was helpful. Again, having the timelines and how much headcount this would need, all that helped getting buy-in from leadership too, right? And again, understanding changing this data, I mean, going to this target data store, what that would mean for the product. Previously, I mean, from memory, the data access on the previous data store, I think I believe it was low single digit number of queries for a certain use case. This changed. I mean, our analysis showed that this would double in the new use case. So we had to talk to our product folks. See, is that latency hit acceptable? How can we parallelize slash make it manageable? And are there other ways to handle the same user experience that can be improved in other cases, but these impacts can be mitigated, right? The other one was how do we do this? How do we do this in multiple stages? We didn't want this to be a full blown one giant migration where we start today. There's the silence from the team for like 9 months, and then suddenly, hey, here's a new system, go switch to it. Right? We didn't want that to be the case. We want to be something more iterative, so we can bring on the front end teams to also A/B test the new target system at different points in time and use that feedback and the impact of those changes on metrics. Right. The other one was kind of data quality and testing that the migration actually is kind of going the right way. When we got up to X%, we marked a few aspects of the original data store that we wanted to be reflected in the target data store or the target data database, right? Things like how many users have how many follows on this kind of entity type. Does the same X% hold in this smaller sample as well? Things like that. Same thing from data quality, right? Like how many entries are missing, how many entries have been wrongly transformed. This should ideally be known before you start it, but knowing what that criteria is helps you run better tests, right, as part of the transformation. And really, having a process around, again, there's the usual process around any other service that you do, like monitoring and getting feedback and getting all logs, and the operational observability side of things applies to data migration too. You find that a data migration is also an opportunity to see if you can redesign your entire system better. If you know that you're going from, let's say, a very simple example of going from SQL to NoSQL, in SQL you have one to many, what does that map to in Cassandra? There are, I mean, it's not as there are no foreign keys where you can join. I mean, you have foreign keys, but there's no implicit joins. So how do you store your list objects in the document store, right? Now, does that change your UI and your backend architecture? So when you start writing these index entries, do you have to do it manually or do you want to do it asynchronously through CDC again? So those decisions kind of surface up, and you can view them from, okay, if I do that, I'm going to incur a freshness of maybe 1 second or half a second, but I can have 10x the throughput because I'm not blocked on doing locks across tables to do a index update. So you can rethink these things as part of your architecture, right? So when you design systems, I would say start with that mindset and see how you can be flexible, how you can be scalable, how you can start putting in checks for data quality in place. If you go really, really, really old school, queuing theory is your best friend. Ultimately, everything is pipes and nodes, but some pipes get bloated, some blocks of data are really gigantic. When how you break them, route them, switch through them is key. And modern systems are no different, right? You just want to think about it.
Absolutely. And another aspect of data migrations is that some technologies, and it seems like it's been getting better over the years, but there are definitely some technologies that are very resistant to facilitating that type of project where they really just want to lock everything into their little ecosystem into their little box, and trying to get anything out is like pulling teeth, whereas other systems are designed to be interoperable and they're designed to be maybe composable. In particular, things like modern lakehouse architectures, where you have these column oriented storage formats, you can bring different query engines to bear for different use cases. And I'm wondering what your experience has been in terms of the progression of years and progression of technologies as to how that maybe simplifies that work of data migrations, and some of the areas that you see as ripe for further investment to improve the end user experience, or maybe even reduce the need for migrations because those technologies can be more easily composed together.
I'm going to have something controversial here.
All right, let's hear it.
And I'm now scared to be quoted on this.
Nope, I like
I
controversial.
think it's really, really amazing that there are so many tools and so many frameworks and so many platforms that are coming up to address different parts of the data migration system. Right? Again, we talked about, in the beginning there was system A that had to be system B, so you can cut the customers off, do a snapshot, reload, and be done with it, and restart the customers and be done with it. And because that's no longer acceptable today, we need to do migrations, at zero downtime with highest levels of consistency and the highest levels of highest guarantees of privacy and compliance and disaster recovery and everything else. So in that context, right, that stuff between A and B is the really complex hairy bit, right? Now you can make the middle bit really simple and say, I'm going to tie in any source you have via some kind of CDC or a pull-based mechanism and directly dump it to a target like S3 or your warehouse or some target, right? Or which gives you batch kind of freshness, right? And then you can, as you start digging into, I want flexibility of which source I can pull from. I want to do a whole bunch of transformations in the middle, so I can take n sources and target m destinations, right? So your things like, for example, data flow is a really, really, data flow powered by Beam, for example, right, is a really amazing pipelining, engine for building DAGs of all these transformations from many sources, many targets. It comes with its own costs and complexities, right? Then you have, the people like, Debizium and I believe Airbyte that give you a very quick and simple, an open source but quick and simple model for configuring these pieces. And then you have, folks like Fivetran who have a much more Datadog like comprehensive ecosystem where they give you, I think, 1,000 connectors and 1,000 targets and many Python options and tunable things, right? These are getting complicated because there are so many configurations to pick from. So there's no like anyone you pick, there's going to be upskilling that you have to do. There's going to be some maintenance. There'll be costs on the compute and storage side, right? Now, for example, they might say, well, we'll keep it, we'll give you full control, but then you have to manage your costs on your side. We'll take everything care for you. It suddenly becomes very expensive, right? Because there's a lot of opaque blobs that you have to deal with. So I like to go back to fundamentals, and this is where my controversial thing comes in, right? If I don't understand it, that's obviously my problem. I'm not saying I shouldn't understand it, but if I don't understand it, I like to know what the trade-off it is proposing and giving me. Unless I know those trade-offs, I'm not going to decide. I'm not able to decide which I want to use. And maybe it's a I was going to say, maybe I'm pampered for having been at LinkedIn and Google for having those tools available to me. But I think what I consider myself lucky for is understanding how they work and why they work, and when they don't work, or at least what I had to pay for making them work. I think when I have that, I'd rather fall back to cobbling things myself because I'm okay with it, so I can see why things are going wrong and where things are going wrong. That's not for everybody there. Data moving and data migration is not your bread and butter. It's not your core business. So starting off with one of these tools is a perfectly good option, right? Finding the right Upwork talent to manage these tools is not such a bad option. But I would recommend understanding them, knowing what the trade-offs are, and not be surprised when you do get hit by the bill.
And in your experience of working in this industry, being involved in data migration projects, and particularly in your current role of helping organizations automate their runbooks, which I imagine involves some measure of data replication or data migration resolutions, fixing things when they break in the process. What are some of the most interesting or innovative or unexpected ways that you've seen teams approach this question of data migrations, whether from understanding whether and how to do it to the technical elements of how they actually executed on it?
Interesting. So our customers are not your traditional tech companies. Our customers are more on the L1, L2 support side, on the NOC and SRE side, right? So they don't deal as much with data as my previous teams have, right? So in a sense, we are building the tooling so that they don't have to worry about these migrations. Now, the scale of our migrations are much lower, by the way, in this company. We actually, again, it's surprising that we haven't used this word till now. We use AI to come up with the right run books, to look at their data, to see what kind of transformations we should create for them. And these are low scale data migrations, low scale, low frequency data migrations. I would almost call them data fixing because of their current engineering practices, data may not always be consistent. So instead of fixing it upstream, they are falling back on tools like us to apply certain rules on what these data should look like. We have one company that was managing bookings for transportation, and a lot of the deletions were done using our tool, right? Deleting bookings that were older than X days, right? Instead of doing it as a offline or a nearline job running in the background, they would just use our tool every X minutes, hours to clean up, to do any garbage collection. So again, given it's a low case thing, we could almost get away with a lift and shift, by the way. But we're somewhere between a series of small batch lift and shifts on much more partial data sets than a full blown migration.
And in your experience of working on these projects and going through these various generational shifts in the tech industry, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
You know, data migration challenges, or the challenges around data migrations, there are the technical ones. A big majority of them are actually non-technical. They're about understanding the end-to-end ecosystem of where that data or that data store fits in, and that means that, like any good engineer in any other domain, right, you have to be aware and interested in being aware of the broader impact of what this piece of data is going to have, or changing that, or affecting that piece of data is going to have, right? Which means understanding the customer experience, understanding the business use case, understanding the priorities of who wants this done, when and how and where and how much they want to spend for this. So yes, there are technical challenges. There are, you can do synchronization, you can do all these. You can read Martin Kleppmann's book on how to do the best replication and sharding. How you can apply the best sharding and replication approaches. But when you apply the real world, that's like maybe 5%, 10%. The why, what, who it impacts, those are really key. And just like that, to manage costs and be efficient, how you project manage this, how you communicate this, how you deal with real world surprises, those are all kind of there, right? I don't see them going anywhere, and it's fine, right? That's okay.
And in your experience too, there I'm sure have been cases where somebody says, we need to move this data from over here in this system to over there in this system. What are some of the cases, or what are some of the heuristics that you use to say, nope, that is the wrong choice, don't do it?
Man, you're gonna get me in trouble now. Wrong can mean different things, right? I like numbers, right? So when I look at a system design, I think of it. I enjoy going into the numbers about how it affects latencies, how it affects costs, how it affects your SLOs, how it affects throughputs, how it affects user metrics. So if your question can mean why and how, right? The first thing is why. Why do you want to do this? I know it's a shinier new system that might get you promoted and get you a bonus, but what is the value of it, right? Now, as to the how, are the components architecturally sound? Do they have? I mean, are they just better technologies, or are there also impacts around how you're going to maintain them? Who's going to maintain them? What is the TCO, or the total cost of ownership of this new, of both the current of the migration process as well as the final output. And that's where I think being a manager kind of helps, right? Like you kind of see that intrinsically. You ask that a lot more naturally, right? And I would say that almost, I mean, every senior engineer in almost any area will be trained to ask these questions. And again, to me, the how is a small part rather than the why.
And as you continue to keep an eye on the data industry, as you work in your current role as a CTO, where you have to have a lot of decision-making power over what systems to use, how to use them, what are some of the things that you are keeping in mind as you build out your technology stack, as you work with your customers and help them in their decision-making process to reduce the current and future pain that they will experience due to these migration projects?
I mean, these days there's so many technologies out there that I find myself getting overwhelmed to. I mean, and I love technology. I love reading about things. I love learning about things. And there's just so many that it's very hard to you know make them out through all the noise, right? And to your earlier point, we talked about how there are so many systems to help in the middle of migration, right? And each one promise a slightly, they promise a lot of delta in certain aspects. And there is the marketing material and there's a reality. These days, it's not that practical to be able to try everything out. So you have to kind of go back to your intuition on what do you think worked, what might work, what is the kind of foundation. I mean, before I go there, different people have different ways of assessing what is the assessing what are the strengths and weakness of an approach, right? My one is basically I need to know if I can understand it, at least from a theoretical foundational perspective, right? If I see that makes sense, then I'm a bit more willing to you know take a trial, take a punt on giving it a go, right? Even for us, I mean, we played around with a lot of vector databases in our product, right? And I mean, I think about a year ago or year and a half ago, there was such a frenzy about so many vector DBs on the market, like Pinecone, VB8, you know, gazillion others, getting like lots of VC money, right? And again, for me, what I didn't quite get was I get it that vector databases are very optimized for putting and getting vector info about something, right? What I didn't quite understand at the time was, look, Postgres is an amazing engine where people have written some of the most complicated indexing libraries for it. Now, yes, being that generic is not going to make Postgres the fastest DB in the world on every benchmark, but it's good enough for our use case where we can put in 1,000 or a million documents a month. Again, we're not Google scale, right? So do I really need something that complicated? And yeah, no, we've been going just fine with Elastic and Postgres for a while, right? And I see the same thing with the customers. The customers get a bit starry-eyed when they hear about a new thing. There's a bit of FOMO around. If I don't use it, will I miss out? Will I be seen as uncool? But really, going back to what is your business? If your business is about selling, widgets, why are you trying to use the most fanciest database out there, right? If your customer is not struggling today, or they won't in the next 10x use case, what does this technical advance give you from a business perspective, or from a customer experience perspective? So I think tying it back to business and customer kind of KPIs, I suppose, is always helpful. I still feel dumb that I don't understand how awesome these specific vector databases are, but I think I'm okay.
So the long and short of this conversation is data migrations are hard. Just use Postgres.
No. I mean, you know what? So back at Street Talk 15 years ago, the I think LAMP was the biggest thing, like Linux, Apache, MySQL, PHP, right? And MySQL was the most coveted, you know, startup DB, for lack of a better word, right? Again, I was not a database person at the time. I was, an embedded guy, and when I read the two, I couldn't tell why one was better than the other. My switch to using Postgres for Street Talk was that it was more SQL compliant. That was the only thing I had to go by. 15 years down, Postgres is still, I mean, you know where Postgres is today, right? Again, it's not about Postgres, but I think if you understand the fundamentals, if you follow your heuristics, it takes you a long way. You could be wrong, and you'll learn something out of it, but don't be scared of missing out on the shiny thing.
Absolutely. Use boring technology. You'll
Yeah,
sleep
yeah.
better at night.
I mean, to me, boring is sexy, right? To me, boring that has a lot of good details, and doesn't make things complicated is sexy.
Are there any other aspects of this overall question of large scale data migrations, your experience of working through them, and some of the challenges that people are likely to face in the process that we didn't discuss yet that you'd like to cover before we close out the show?
You know, I mean, there's always going to be more, right? A few things that I keep thinking about. I mean, I've been reading a lot about data virtualization these days, right? And I think if you look at data lakes and data warehouses, they kind of give you an aspect of virtualization. The idea being that you have all this data, why don't you just create views out of all these sources without physically moving it anywhere? How practical it is, I'm still, my numbers aren't adding up. I mean, there's always going to be a use case where that works. If you're okay with the latency guarantees in terms of, let's say, for example, creating one-off, infrequent, detailed reports that need to join 1,000 data sources, sure, that works. If you need a very live user, dashboard being served to millions of customers, it's going to struggle, right? The other one I've been again hearing about, and I'm trying to get past the labeling aspect of it, is data federation. Again, how do you bring different kinds of data in different transformed ways to different customers, right? Seems like a very broad problem, but I think the details are where it's going to be interesting. We spoke about replication, right? I mean, replication is I suppose you can treat everything as replication, everything as a migration, everything as a move. One thing I really wanted to talk about, at least briefly, was this replication scheme that I came across from Netflix, called dblog, right? I mean, you have DBZM, you have Databus, you have HVR, and a whole bunch of things that do replication for you. dblog was so simple and beautiful. It works by creating these watermarks in your data stream, or your data change capture stream, so that you can actually do incremental, replications, very live manner, instead of waiting for a whole dump of a snapshot. Definitely worth reading. I'll happy to share that link as well. And yeah, I think we haven't. I know we focus a lot on data, right? We didn't talk that much about how should the application and application teams and double quote front end teams react to all this. I think that's interesting thing as well, which I can jump into. Yeah, I suppose there's so much here, really.
Absolutely. And in particular, I like you calling out the inclusion of the application teams in the process, because if you're trying to do it all from a single point solution perspective, then you're going to be having everybody in the organization, their whole weight bearing down on you, waiting for this to be complete, because either you're breaking things or you're making them move slower, when really the entire organization should be moving in lockstep to achieve that end goal. And in a lot of cases, the application developer can simplify a lot of that work, because maybe you don't necessarily have to have all of the data completely synchronized in both systems. Maybe they can write to one system and accept latency in the read from the other one, or maybe they can handle the double writes so that you don't have to handle as much of it in the back end, or just incorporating them in the overall planning steps as well can help reduce the actual complexity of the move.
Yes, with a double exclamation. So I mean, I know I missed this in the trigger earlier, right? Sometimes data migrations happen because you're trying to save toil for certain teams. Now, very, very small startup, that is just one team. There, your problem is, should I prioritize this migration now? Because teams under toil, or can we wait for customers, 3, 4, 5 customers to come on board and pay for this migration? In really large organizations, this problem is kind of, the symptom is similar, but it's framed in a different way. You have 1,000 teams with their own priorities and their own roadmaps and their own kind of monthly, quarterly, yearly OKRs. It becomes a prioritization problem, like why now and when and how and so on. So the teams coming together to walk in lockstep, that's ideal, but often it's a bit more coerced, in the sense that the teams have to see value for them first. Application teams might say, look, I was using API 1 before, my application is working fine. Why do I care if you change or if you migrate this data now? Now, if the answer is purely because it'll help us manage it better, that's not a good enough answer. But if the answer is doing so will help you unlock those 5 things in your roadmap that you can target now rather than wait for 2 years, is that valuable for you? So I think that's where addressing the user concerns, the business priorities and roadmaps, like all that kind of, all these non-technical people problems kind of are important.
Definitely. Yeah. And as technologists, it's definitely easy to fall into the trap of, I'm just going to engineer my way through this, when just talking to people can save you a lot of time.
That's right. Be on the latest and greatest, baby. That's right.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
There are a few actually, right? And again, I know I keep saying this. The silos in an organization are problematic, right? As organizations grow, as companies grow, for better or worse, they find their own ways of doing things, and that changes, how they manage data, access data, control data, process data, and so on. So, effectively, you do have data silos that have to be managed and have to be worked on, right? So tooling has to somehow, a tooling and framework, right, have to somehow bridge that gap and make it easy to, work across silos. Also, again, over time, for better or worse, organizations end up having a lot of bespoke and manual and non-standard processes, as they grow. I know a very knee-jerk reaction to say, hey, let's have a central data org. This brings its own problems, right? You're talking about functional versus feature teams and hybrid teams and so on. Tools need to kind of ensure that you can take in whatever manual process you have today and onboard them into this tooling, rather than force everyone to change their process just for the tooling, right? Again, I know it sounds like a buzzword, but AI actually can go a long way in transforming those manual things into these tools, right? The other thing is, collaboration is one aspect. Like, a friend of mine was talking about data usability and data accessibility and data collaboratability. Like, how are different roles and responsibilities in an organization coming together on a single piece of unified data fabric or whatever, right? How they're able to make sense of the data in a way that's secure and compliant and so on. And I think here's where the idea of virtualization kind of makes sense. And if it is performant, it'll go a long way. So you can actually avoid the data moves. Cloud helps here because again, cloud is still a vehicle. It's not the final point, but it can help here, right? And I guess standardized tooling and standardized APIs, the other way to look forward to. But again, you have a lot of friction in the organization that is more people and process oriented, not necessarily technical oriented. Yeah, I think as these areas kind of evolve, there's definitely a lot more innovation and a lot more tools and a lot more frameworks. Because we all want to see that world with seamless data management and integration.
All right. Well, thank you very much for taking the time today to join me and share your experiences of going down these hard paths of data migrations and some of the lessons that you've learned in the process. It's definitely always great to hear from people who have been in the trenches and done the hard work. So appreciate all the time and energy you've put into that in your various roles and your time sharing it with us today. And I hope you enjoy the rest of your day.
Thank you, Tobias. It was really, really fun being here and, a great walk down memory lane.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.